In the following video, I'm going to run through how we can take a point cloud like this and convert it into something like this. Okay, so we're going to use a new tool, or we are going to use an extension of an existing tool that allows a template to be passed through the point cloud to try and best fit a particular section to the point cloud. So the starting point for this is to create a section, something that we can use again and again to match. So if I turn off the model, all I've got in here now is the point cloud. If I zoom into a column and under sections, I'm just going to use the quick horizontal slice tool and click there. Okay, so we can see a section, all right? If you need to adjust it, you can use set center. Okay. We have a basic outline of the steel column we want to use. I did actually download a spec sheet for all different types of steel columns. Okay, but I've since discovered that a lot of the columns in this particular point cloud don't seem to be standard. So what I'm going to do to begin with is I'm just going to quickly measure some of these offsets. So what I'm going to do, I'm going to quickly measure some of these dimensions just to see what kind of section we're dealing with. So under tools, measure distance, direct, and I'm going to tick free select. I don't even have to click anything in the point cloud. And I'll go from there to about there. So 215 maybe there, and down over here. So 215 would be about there, so it's potentially not 215, so maybe 205. In the middle could be about 9, and here about 10. So we've got some rough dimensions, okay? So what we need to do is create a template we can then use to then try and match, okay? So what I'm going to do is I'm going to go to the Cadd part of the software to begin with and draw this manually in Cadd. I'm going to create a new Cadd model, not worried about its name. Go to full screen on that. Just flicking back, I'm going to draw a box to begin with. This is 215 wide by maybe 205 deep. So I go to rectangles, normal. Change this draw mode to relative, and then in the box down here, I'll have 0.215 by 0.205. Click anywhere on the screen and hit create, and then double middle mouse button. Okay, so there's the outer rectangle. Now I'll come out of relative. We don't want to use that anymore. Flick back to the point cloud. All right, so for argument's sake, I'm just going to create the flange and the web both at about 10 mil, just to demonstrate how we would draw those. So you could do this in AutoCAD and bring it back into n4ce as a DWG. It doesn't really matter. I'm going to go to explode on my rectangle. Now it's been exploded, it's now lines. So I can now go lines, parallel, single. Let's go 0.01. So there's that one, and there's that one. Now I need to do a single line and press M for mid, going from there to there. Okay. Now we just need to offset that 5 mil. On that. Now I can delete what I don't want in element mode. So that one, and that one there. Now the chances are there's probably a radius in there that I need to check. So if I come back into this view here, you see there is indeed a radius of sorts. So if I go to digitize and if I do find circle, okay, it'll start drawing a circle. Don't want to do quite like that. So what I'm going to do is I'm going to define. Okay, doke, and it reckons there's probably a 12 mil radius in there. That'll do for me. I'll just hit remove to get rid of that. So back into the Cadd. Okay, I need to first of all gap this. So under lines, I'm going to go gap break. This will create a proper hole, in other words, leaving with 2 polylines. Click the line I want to break, and then in end lock mode, go from that end to that end, and then repeat for down here. That's my line, and then from there to there. So in the end lock mode, it automatically sorts the start and end out of the break. Now I need to put in a curve. So we're going to go to arcs, tangent, line and line. It says what's the radius. Okay, and I think it was about 12. And go like that. And do the same here. And do the same here. And do the same there. Okay, and now I need to join the ends of these lines. So then go lines, join, join, join. And we don't need to worry about that because it will be automatically closed later when we do the template. So that is our basic column profile. So I need to create a template of that. So I'm going to go normal, column for now, and I'm going to backplot it with the Cadd section I just drew. Zoom to extent. Okay, so there are some arcs in here which I need to do first, and I'm going to generate from lines. So we're going to go to points, generate from arcs. Just use anything that draws a line, so say BB for now. Obviously, these are quite tight radiuses, so I'm going to have to put in here, shall we say, about 5 mil, so I get some points around the arcs, around the circumference. I'm not worried about the height. Press OK, and in rectangle mode, do those and in those. Obviously, I'm not worried about any levels or anything, so I'll just turn all that number and height off. Now we can go points, generate from lines. I'll do check for duplicates so I don't create any points on the tops of the arcs. I'll set the spacing back to 0. Press OK. Okay, that'll be fine. So if I then get rid of the backcloth, okay. So I need to do some joining up now. So it's lines, join from there to there, from there to there, from there to there, from there to there, from there to there. Don't worry about the curve, we'll do that in just a second. That's a point out on its own. So we need to do apex append on that one. And just recode it. Right. So because of the curving here, we need to stop that curving. So I'm just going to go to curve, tangent segment, click that one, click that one. There we go. So that is our basic template. And now all I need to do is create 3 more points, which are going to act as the handle points. We're going to call them P points from now on, because when we're doing the rail, the P point is the theoretical running edge that we want to basically find. But when we extract this as actual points, you have the option of creating the P points as well as the extruding of the template. So you can actually create points wherever you want over this template. So for now, I'm just going to go points, insert, give it the code P, and null height. Okay, and in end lock mode, I'll duplicate that one, and duplicate that one. Right click. Now I need a point in the middle. Okay, so the P points need to be in 3, so you have a point at either end and a point in the middle. So I just need to quickly go to settings, codes, and just get it to draw a line for the P. So I'm going to add in P, duplicate that. So now I get a line. Now I can go to lines, densify, all number of segments to, there we go. Okay, so we've got our basic template and we've got our 3 P points. And there they are. Okay, so we need to turn that into a template n4ce can understand. And the way to do that is just go to the list tab, hit invert so everything is selected, then click to block. Want to know where the origin of the block is. It says indicate origin there, so I'm going to indicate, change my lock mode to point, indicate the center, right click. Okay, and I could now say, so 215, should we say, times 205. Okay, and that is now a block that we can use. It's now put up in here as a coordinate block that we can use to refer to whenever we like. Okay, now drawing these sections by hand, okay, it doesn't take too long, but it's obviously a bit of a pain. And if you need to do lots of different sections, you're going to be there drawing up sections in Cadd and going through this process again and again and again, and it get a bit boring. So because we've got the Python API, there is another way of doing this. So I use ChatGPT just to sort of cut some corners, saves a bit of time. And essentially, I just asked it to write me a little program that will draw the cross section of universal steel beams and columns. The input will be width and depth, the web thickness and the flange thickness, and the output will be a vector drawing of the steel beam or column. And this is what it did. Okay. Now I realized I didn't want a vector drawing in a image format, so I actually then asked it to convert it to a CSV. Okay. And it gave me some code. And here is the basics of that code. It wasn't perfect, as I'm sure some people have ever tried to program with AI before. Code isn't ideal, isn't perfect, needs a bit of love, shall we say, so I need to breathe on this a bit. But now I've created two routines. One that will do a universal section based on the width, the height, and the flange and the web, and a fillet radius. And I extended it as well to do universal box sections. Okay, so if I scroll down here, we call it basically by the name of the routine we want to run, and then we put in the numbers we want to use. Okay, so in this situation, I've commented out the boss section, and these are the parameters I'm going to use to create my steel section. To run it, I just go to the models folder, go to plugins, and what we do is we run the Python script. So if I just quickly show the Python script, technically it can run from anywhere, but I've actually put it in a special folder underneath the applications in Cadd under program data and in plugins, just called steel section, and that's what I want to run. Okay, and it has created the model for me. So if I double click on that, go to the camera, there we are. Okay, so here's my steel section. So if I go query line, okay, and then we've got the 3P points running down the center. Now to turn that into a coordinate block, I could use the list and invert the list and do it that way, or you can just copy and paste it because it's already centered. So copy, new, put that in as the name, and then copy those in. There we go. All right, now, okay. So that's the basis, right? So now I can create a section of any size I like. So let's start afresh. Create a new model. This one's steel. And here's my point cloud. All right. So let's just refresh our memories as to the size of the steel that we need. Okay, so the width is about 210. The depth could be about 210 to be fair, to be the same, to be honest. And that's about 10, and that's about 10. And we said that that was about 12, didn't we? So (210 by 210), 210 by 210, and let's have 10, 10, and I think it was 12. Oops, don't forget that comma, else it won't work. So we'll save that, and then in Pythons, we'll just run the file. All right, and there we go. Into extents. There it is. If I just click solid lines, that's all good. Obviously, my P point isn't strong anymore. It doesn't need to be. Okay, n4ce knows what to do with it. So what I do is select all of that, copy that, Control V that name in, and then copy the data, paste. We can now go into the point cloud. Because I've added that new coordinate block, I need to just go and refresh the view so it knows it's there. Now I'll delete all my measurements. So the tool we need to use is under feature extraction. So this is part of the feature extraction bolt-on. It's not part of standard designer. I'm going to go ICP. Okay, now ICP stands for iterative closest point. It's an algorithm that you would normally use to align one point cloud to another. Because there's no other coordinate block to pick from, it's chosen the one we wanted to use, and as you can see, we've got something of a match. Not perfect, perhaps, not yet, but we've got something of a match. Okay, so the way iterative closest point works is it's trying to match the points in the template to the points n4ce is showing it in the section. Now we can see here that we don't have points so much on the inside edge here, okay? And what we can do is if we expand this out, we can actually tell n4ce to actually omit certain parts of the template. If I go from there to there and then do 0, okay, and then do from there to there and hit 0, it removes them from the template, okay? That's still not ideal. So I need it to consider the edges with a bit more of a preference, okay? So let's see what happens if we do the same here and here. Okay, and now I think that's not so bad. Okay, if we scroll down to the bottom, okay, now the other issue we've got is that where we have information like this getting in the way, we'll need to use, the set polygon function, which allows us to omit information we don't want it to use. There we go. So now even though there's information out here, it's not going to get in the way, not going to be considered. Okay. If we scroll up, okay, obviously there's going to be a small error in the scan data, so I'm reasonably happy with that. If you want, you can assume the start and the ends are the only points you want, and we can just put it into 2-point only mode, or we just put it into ends only mode by doing this one here. In that respect, we're just going to do the first and the last. Okay, but if it's bowing in any sense, you won't pick that up. So if you untick ends only, at the moment we've got a section interval of 1 meter. You could change that to half a meter, and then to see how well everything fits, you then hit fit templates. Okay, now everything's gone red, probably because we haven't given it the good rotation. We haven't told it which one is a good rotation to use. If I hit good rotation, that goes to 0, and now 13 out of 16 have passed. Okay, we've set the maximum rotation by default to 1.5 degrees, and at the moment the maximum error is 4.5 mil. Okay, depending on your data set, you might have to change that depending on how you want to work, but you can see here that's a reasonably good fit, and that's the kind of fit the score overall. So you have to work with a certain sense of realism. Scan data does have an element of noise in it, even the best scanners in the world, especially on shiny surfaces. Okay, so if you're happy with that, you can now just say, okay, let's keep it. So I could do digitize p points. It'll create a point in the middle with the rotation information on it and the fitness score. But for now, I'm just going to say extrude. And if I turn the point cloud off and cancel the tool, okay, there it is. So it's literally a process of repeating that now. So if I turn the point cloud back on, I want to do the column next to it, I can choose set center, click on there, go back to the ICP tool. Okay, now I will obviously need to reset the set polygon. Sorry, I now need to hit draw polygon. Okay, so that localizes it. If I slide it down, okay, now I think that would probably be a good place to finish. So what I'm going to do is I'm going to come up to the top here, and I'm going to click set. That sets the end of that one. Actually made the other one a bit too short. Okay. In ends mode, it doesn't really matter because it's going to do the first and last anyway, but I've just moved it down just on the off chance it didn't start low enough. And then we hit fit templates again. Say 14 out of 17 have passed. So the ones that haven't passed, if I double click this one, you can see there was a bit too much noise in the way. Ultimately, it might actually be okay. It says failed because the fitness score in there, there's a lot of data in there that it's obviously used, but to be fair, it actually does seem like it lines up all right. So in that situation, you can actually say use that, and if you click use current fit, it'll then say overridden, and it'll then use it. So, similar with that one, I can use that one. Okay. And when you're happy, you can either digitize the P points if you're just interested in the center line as a point, or we can hit extrude. So turn the point cloud off and just turn the sections off for a moment. Cancel the tool, right click. If I click wireframe only, there you go. Okay, so you have ultimate control over the accuracy and the validity of the extraction. It'll work exactly the same way as for horizontal sections. So let's just show that happening. So I'm going to delete my sections. Okay, so to do the columns, I just use the quick vertical, so the quick horizontal slice. But here I need to do a slice in a certain direction. So to start that off, we're going to use this option here, multi-plane. Control click just to zoom in. All right, and I'm going to pick an edge which is consistent all the way down. So I'm going to say from there, and then control click down here into here. Okay, and then right click. It's very important that you right click, otherwise it will carry on trying to draw a multi-path section, which we don't need. So if I go back and click on show path, there we go. So we have two sections we need to extract here. We have the standard eye section and we have a box section. So let's start with the standard beam. So we'll measure it like we did before. So under tools, measure, direct with free select on. So from there to there, it's about 145. About 405 there. Could be about, so it could be 10. And here, yeah, another 10. So we'll go 145, 405, 10, 10. So into our code. Okay, so 145, 405, 10, 10. Oh, and we need to know the radius. So we'll go to our digitize and we'll do find circle, define. 15. So we can move and do that. Down to 15. Remembering to save it. Then we can go back into the project manager. Okay. And then if we just hit run script and run the existing one, okay, and it'll just do it for us. And there's the new one, 145 times 405. So I'm going to copy that, Control V that into there, select all the points, copy that, paste them into there. Now flick back to the point cloud, delete my measurements so they're not in the way. Delete all. I need to refresh the view so it sees the new coordinate block. Under feature extraction, go to ICP. Now it's got the wrong one in here, so I need to change it. There we go. Now there's obviously other data inside this section that we don't want it to use. So that's where we come down to set polygon. Oops, draw polygon. 2, 3, 4, right click. Right, now that one at the start is working pretty well. Just make sure it's also fundamentally in the right place there. Yes, it is. So I'm going to just reset the template so we get points all around the template now. 0 on the top. There you go. So that now that's done that. And okay, so that's given us a reasonably good match, I think. Fit templates. Oh, forgot to do set good rotation. There we go. And now we're getting 34 out of 34 passing. That looks pretty decent. So we're going to hit extrude, close everything off. Okay, and there we go. That's worked nicely. And we'll just do the boss section to complete the demo. So the box section, if we just measure that, so if we go to tools, measure direct, we'll go from there. So probably 205 in there, and $12 again, I think, in there. So let's come down 11 or 12. I need to comment out the universal section, enable the box section. We'll say 205 by 205 by 12. Save that. Click on models, run the script. There's our box. Copy that, paste them in there, and then get the data. Okay. Back into the 3D view. Going to go and clear the measurements now. And obviously remove that. And go to feature extraction, to the ICP tool, and change it to the box. And obviously we now need to set the polygon again. Okay, now reset. Now it's pretty obvious to see that we can't use the entirety of the template because ICP is very much a like-for-like kind of tool. We have to compare the right points in the template to the right points in the point cloud. So if I click on there and come around to there and set that to 0, hopefully when I press 0, there we go, snaps into place. I'll just reset that and just, there we go, that's better. Okay, so I didn't want to pull in too many points from the top because that was altering the rotation. And double click down there, so obviously it runs out of data there. That's okay, it's pretty much tying up. So we're going to hit set good rotation so it knows what to use as a good rotation, and then hit fit templates, 29 out of 34. So obviously the ones at the end aren't great because the actual data you can see disappears, so we're not going to be able to extract those. When this actually becomes a primary release, there will be a tool to essentially extend the end. So if the data does that, you'll be able to just drag it out further and assume that's what it looks like. But obviously they failed, but for now that's fine. So we're going to hit extrude, and then I cancel everything, delete the section, and turn the point cloud off. There we go. Okay, and that's fully exportable to DWG as a 3D mesh, or to IFC or to OBJ. Okay, so it's really just a matter of creating the right sections that you need and assigning them to the various parts of the point cloud. It's Actually quite straightforward. Doesn't take long at all. And it will be as accurate, hopefully, as your scan data. That completes this presentation.